Hi friends, and welcome to yet another session of NITCO Talks. We have a fantastic panel today, and we hope to have a great session. And I hope you all enjoy it like we've been enjoying the earlier sessions. I'll do the introduction. Yatin Patel, unfortunately, is having some connectivity issues from Alibag beach. It's not easy to get the same connectivity from a beach, but he's trying. Yatin Patel, Yatin chairs DSP Design Associates as founder and principal, having established the practice 3 decades ago as a first-generation architect. He has spearheaded the organization to achieve service capabilities across an array of verticals within architecture and interior design, across domains like master planning, mixed-use developments, high density, and residential. Under his leadership, DSP Design has been inducted as an exclusive Indian architecture and design practice to One Global Design, USA. Globally, DSP Design is currently standing at number 55 among the top 100 architectural practices worldwide and third among top 10 architectural practices in Central Asia. Truly impressive. Welcome, Yatin. I hope we get to see you as well.
Well, thanks, Vivek. I'm still trying to get on. I have
okay, doesn't matter. It doesn't matter.
Connectivity, but I will keep trying. I will keep trying.
Thank you. Thank you.
Karl Wadia. Karl got his master's degree from the Graduate School of Architecture, Planning, New York, and joined Architect Hafiz Contractor as a trainee in the year 1999. He has been involved with and contributed to several iconic projects across various sectors, be it master planning, residential, commercial, institutional, or government buildings. His key projects include Island City Centre master planning for Bombay Realty, academic expansion of BITS Pilani in Rajasthan, the Nairobi Eye, Kenya, and many more. His studio at AHC has been responsible for designing India's largest 100% net zero energy building in Jaipur. Welcome, Karl.
Thank you, Anikaa. Looking forward.
Kapil Gupta. Kapil is the co-founder of City Architects and the principal of City Mumbai. He graduated with honors from Sir J.J. School of Architecture in 1996, followed by postgraduate studies at the Architectural Association, London. He was a director at the Urban Design Research Institute, Mumbai between 2003 and 2008, where he led India's first entry to the Venice Architecture Biennale in 2006. He is currently the Charles Correa Design Chair at the Goa School of Architecture for 2020. Kapil leads and manages City's project portfolio in India, ranging across housing, commercial, and the institutional sector. While he has a string of the most enviable awards to his credit, the latest one was his winning of the IFI Design Distinction Awards, learning NUS School of Design for Singapore. Welcome, Kapil.
Akhil Ganatra. With roots in the built environment sciences and engineering from Singapore and UK, Akhil has successfully marked his position in the field of design and engineering and project management for the last 15 years as the managing director of Clancy Global. He is intuitive and skilled at taking up new challenges for managing tight deadlines and cost efficiencies, applying innovative frameworks and technologies for consistent delivery at volumes. With more than 280 million square feet of engineering design delivered with Clancy Global, Akhil finds a keen interest in bringing application to sustainability and smart city adaptations. Welcome, Akhil.
Thank you. It's great to be on with all of you. Really looking forward to this conversation.
Our topic for today is smart assets and role of designers. And we're going to see some presentations from all the designers. And so I can request Karl to go first.
I
And
think Akhil is going to start. So he's
Akhil is starting. Okay.
to what we're talking about today, and then the designers will go.
Okay. Akhil, all yours.
I'll just set some context in terms of what we've sort of discussed as a group and how we're going to pursue this topic. In terms of showing my presentation, I'll go last because let all the designers show the stuff that's going to really get made. For us, it's more the back-end engineering of it. So just to introduce the topic of smart, what is smart asset is the first question not only we as a group ask, but anyone who's attending this is going to ask. It's this elusive term where you think that magically everything is going to come on a screen and life is going to be more efficient. So today's session is to see how different asset classes can become smarter. So the first thing as a group, all of us agreed was that sustainability is a default measure. Passive measures, net zero building, and especially with funding for green being available, every building can be net zero for the sake of argument. So Yatin, Kapil, and Karl, all three of them will cover a great amount of sustainability in today's conversation. The next big word for the decade is data. So as a group, again, we said that, what is this data analytics or what is this elusive word of artificial intelligence and where does it emerge out of? So the first thing all of us need to understand, and we understand as a group, is that as long as the workflow is understandable, the data intelligence is intuitive. More often than not, what we end up doing is getting carried away with software and ye bhi kar sakte hain thoughts. So it becomes an illusion of visuals. Today is going to be about uncomplicating the nodes of smart, where less is more. Just trying to track more and more things and having the ability of doing it is not smart. Finally, at a note of its own, before Karl takes over and starts showcasing a project, inclusive and heuristic is the way in which smart can be brought forward. It is intuitive, and it is the designers like we have on our panel today that have that intuition or instinct to know how an asset will function. Only if we are responsive to how the asset is going to function, we are going to be smart. By changing everything around is not what makes us smart. Service as a software or SaaS is something that even designers will need to start looking at, is because the context with which they've designed their asset and whether that asset has moved along operating with the same context or not is going to become very, very important. So finally, before we move to Karl, it is about being intuitive, a trained instinct of a designer, and being responsive to what the asset will do. Rigging up of hardware and software for data points is the simpler thing to do and very functional. That's the table for today. And Karl, if you'd like to go ahead with your project.
Just one thing, when we talk of net zero, what exactly does net zero mean? The audience would want to understand what is the meaning of net zero. So who can tell? Karl, you tell us that?
Yeah, sure. So before I take the presentation, net zero is, the word doesn't stop at net zero. It's net zero what? Net zero waste, net zero energy, net zero, whatever it is. What we've spoken about in yesterday's conversation, or net zero carbon. So what we've spoken about in yesterday's conversation is, let's talk about, let's sort of unbox the meaning of net zero in simple terms. Let's start with net zero energy, because that's the easy one to deal with. At least that's what we thought a decade ago. And I suppose the next objective in the next decade or maybe 2 decades is for to start with designers and then the whole industry and sort of fraternity as a whole to take over and adopt this concept of net zero carbon. So it is as simple as whatever you put in has to be offsetted by the same value. So if I require 1 megawatt to run my building, I should be able to produce 1 megawatt of energy to subset that. So my footprint on the planet for that building is net zero. I mean, it's as simple as that, you know. And uh, when we got ambushed by this concept of net zero a couple of years ago, after dealing with it for so long, we've been able to concise it down into one simple sentence. And I don't know, Akhil, if that's the right answer. You're the
Hey, agreed. I mean, simplicity is what it is about, buddy. I mean, only if it's simple, more people are going to, or more assets are going to be able to do it. So it's great to simplify.
The first time, Kapil, you're on mute. The
No,
first.
so I just wanted to add to what Karl said, you know, which is exactly, you know, how you think about net zero. But I think whereas architects, this begins to actually kind of translate is how do you really begin to design and create a net zero energy building? So one is obviously where you understand that you know, you have a certain amount of that your building kind of needs a certain amount of energy, since we're talking about net zero. This is here where the ingenuity of design comes in, where through kind of passive design, through intelligent design, through, you know, often very common sense ideas, one can begin to reduce the energy demand of the building. So, you know, you can't say, I'm going to build a power hungry 5-star hotel, which is fully air conditioned, and I want to make that net zero, right? So you're already you're already kind of killing yourself. So the point is that as designers, and I think this is really the aspect of the, you know, which is what we want to talk about, is that the role of design is to fundamentally see is that to achieve kind of, let's say, net zero, how do you, or smart assets, how do you begin to design them in a way where their input, you know, where the inputs that go into the building itself can be substantially reduced. And I think that's really what we're going to talk about today.
The first time I came across a net zero building was when I heard it from SOM Architects, and several years back they had designed the Pearl River Tower in China, I think in Guangzhou, where they told us that they don't consume a single bit of energy externally. It's all self-generated. They had micro turbines, they had wind turbines, there are all kinds of things.
Right.
And but that time they were saying it was very expensive. Now, if you're talking of net zero and implementing it, it possibly can't be the expense that once used to be.
It's not.
In fact,
It's
free.
not that much anymore with it. Yes. Virtually.
Karl, all yours.
okay. Is the screen? Can you see the screen?
Yeah.
Yes.
Okay.
It's not on full screen though, so if you want to make it full screen, just yeah.
Perfect. Okay. So I think Kapil talked about it, and to make it simple, net zero. You know, the analogy of the 5-star hotel. I think one has to first think about how to design the building to consume less, and then you try and make that less into net zero. I think that's the efficient and the right way to do it. And for that, you know, we need to look at comfort, health, energy, and biophilia. And you know, we in the studio, we call it the process of informed design. So we're going to focus on two projects here. One is a net zero project where we've actually achieved net zero energy, and the second is a net zero carbon project where we aspire to achieve carbon neutrality. One is completed and one is in the pipeline. So the site we're looking at is the Manipal University in Jaipur. Very, very hot and arid climate, cold in the winters. But what you see on the screen is a couple of images of the campus we built, which is spread over about 150 acres, 2 million square feet. It's been awarded a Griha 5-star rating. Over and above that, it's also We have a hostel campus of almost 3,000 rooms, 6,000 students, which is a LEED Platinum as well as Griha 5-star. And what's important is that in this campus, we've actually designed, built and gone back a year later to measure the data for India's largest and the world's third largest net zero building when it comes to energy. And none of that energy is taken, offsetted from the system by paying for it. It's all generated at site. So in that sense also it's net zero. What we want to show you on this with these images is that the campus really captures the flavor of Rajasthan in a sort of semi-contemporary way. As you can see, everything that you see on the screen is painted. So budgets were extremely tight. So we want to get rid of the myth that net zero buildings are expensive. So we started this entire master planning with looking at how old cities are planned in a sort of very medieval interlocking streets and narrow views and very compressed movement. And you can see the sketch on the bottom left is one of the first sort of concept ideas that we had with Hafiz when we started designing this building, this whole site. And that was to sort of recreate the old Rajasthan towns. And because sometimes the answer lies in front of you, where everything is there just to be, in a sense, adapted or copied, for lack of a better term. So we took the site, we parceled it up into two small villages with a sort of central village square. That was the concept. And we had to divide the site between the girls and the boys housing. So we wanted to make sure that, if you're creating a village, there has to be a sort of town center. And what you see on the right-hand side is, besides having to deal with all of the net zero and everything else, we were really dealing with a very compressed timeline. And in about 2.5 years, we were able to develop an almost 35 to 40 acre site with a 6,000 student capacity and all supporting facilities, landscaping, everything in less than 2.5 years. So the timeline was quite compressed. And you'll see the image when we sort of took over the site versus now. We've, besides making everything net zero, we've significantly greened what used to be arid landscape. So that's also in a sense been a contribution. So we've done all this with we do use technology a lot. Whether it's Ladybug or Autodesk Flow or UMI for Urban Daylight or Envinmet. We use technology to study what we're doing, to calculate the irradiation, the wind flow. We had to make sure that the thermal and perceived comfort at the ground floor when students are moving around the place is also very, very comfortable. Otherwise, the whole concept of biophilia fails if you have people wanting to stay indoors all the time because it's more comfortable. You need to drag them out of their enclosed environment and more connected to nature. Now coming to facts and figures. So what you see on the top left is the average is about 90 kilowatt per square meter per annum. We had a design objective of 35 kilowatt. And for the hostels, we had a design objective of 50 kilowatt. Air conditioning wise, the average is somewhere between 300 to 350 square feet per ton. We had an objective of making it 600 square feet per ton. So this ties into really what Kapil said a while back is, we don't want to design something that requires more tonnage to air condition, but rather use passive architectural moves to bring the requirement down and then deal with the lesser requirement of, when we design. So what we ended up achieving is we did our entire MEP design based on the the architectural moves that we made for the campus. Every east, west, north, south, the chajja dimensions were different, the boxing was different, the insulation requirements were different on every single wall, depending on where it faced. And we actually ended up doing this building in less than what we even calculated. So our net zero building has an average air conditioning square footage of 650 per square foot of, per ton, and 950 per ton for the hostels, which when we've tried to apply these figures to new projects, we get a lot of kickback from clients as well as MEP consultants that this simply cannot be done. And here on this screen is what you see is the simple explanation of net zero. So we required to consume around 35 kilowatt per kilowatt hour per square meter per year. And we have an on-site generation through solar and PV, as well as on the car park of 35.8 kilowatt hour square meter per year. And the screen on the left, if you recall the timeline, we left off in 2017. So if you can see this, the image on the left from August 18 to July 19, we have a graph given to us by the Institute on the consumption versus generation. So you see that most of the time the generation is slightly more than the consumption, making this truly a net zero building. These are some of the images. Most of the paving is being done with waste stone from quarries. What you see on the right hand side, these are the cutouts for getting air circulation through all of the spaces. And this is the whole look and feel of the campus. It's actually a very nice place to go and just spend a day. So the next agenda for us is to get to zero carbon. So these graphics tell you where we are today. We're about 4.2 tons per person, and we require, each person needs about 200 trees to offset their carbon requirement. And where we need to be is at 0.6 tons, which is about 29 trees per person. So that's a sort of staggering difference. Fortunately, in India, we're at 1.8, which is less than half of the world's average. And how we're going to achieve this, I don't know. But just to let you know, one flight from Bombay to Calcutta and return is 0.6 tons. So if you take one flight per year, you can't do anything else but sit at home. So I don't know how we're going to achieve carbon neutrality, but let's see. So we are designing one more campus now in Calcutta, where the client came with all of these requirements of Griha 5-star and this and that. But we said that we want to go much beyond that. We want to do a zero carbon campus. And how do we do it? So we've been working with Swati from Terra Viridis very closely in Hyderabad, and we've been trying to figure out how to actually make a zero carbon campus work. And the way we do it is we need to first calculate the carbon we consume, and then we need to calculate the amount of carbon that we can sequester, and that would give you zero carbon. So we consume carbon through lighting, air conditioning, refrigeration, diesel, cooking, transportation, going back and forth to the place of work. There's a lot of embodied carbon from material to transport to building construction. And the way you offset it is through a lot of renewable energy, through a lot of biogas preparation, using water bodies if you have, a lot of trees to offset the carbon, to create edible forests, so to be self-sustaining when it comes to food, so you avoid a lot of other functions like transport, etc. And what we did is we created a roadmap for the institute from 2023 to 2050. How are we going to get from step by step making this a net zero campus, a net zero carbon campus? And so every 3 years we have one objective where we need to meet that objective, and I'll try and show you how we're doing that. So we need to all constructions now on need to be net zero. We need to have a net zero energy, net zero water, net zero waste to landfill ratio. We need 100% food flood resilience on the campus. We need to take care of health and well-being by making the campus not only safe, but feel safe. We need 100% food self-sufficiency. And obviously you have to increase the biodiversity on the campus. So we took this 135 or 150 acres and we divided this acreage between, what do we need for building footprint area, roads and pathways, how much vegetable farming do we need to support 6,000 people on site, how much permaculture do we need to grow fruits and be self-sufficient. We could manage only 10 acres of useless landscaping where it's only visual and not functional. We had to create forestry for the carbon offsetting, and how much area we need for bio-waste and lakes, etc. So these are actually, we did the calculations, and so this leads you to, you need this concept of farm to plate, where you grow it on site and you eat it. Obviously, this changes in an urban environment like Bombay, where you have space constraints, but where you have the chance, I think the chance can be taken. Waste management through the concept of circular and economy, trash to treasure, and there are so many other concepts that are now doing the rounds internationally. You have this idea of repair cafe, and waste management, taking care of all the construction you produce on site. Try and do buildings in steel. It goes back into the recycling system, aluminum, etc. And this was a sort of concept of the overall master plan from an energy, waste, biodiversity, food, etc. Point of view. This is just a glimpse of one net zero building that we're designing. So starting with elevated stilts to allow for winds to go across for thermal comfort, to appropriate depth of floor plate for natural light to come into the building, naturally ventilated corridors, shaded because this building had to be east-west. That was the only space available. A solar PV roof, buffering spaces for thermal buffering, obviously roof rainwater collection, clear story windows for deeper light penetration, and orient the buildings to catch the appropriate wind, etc., etc. Thank you. That's it from me.
Really fantastic, Karl. Superb. It's great work done. Really great work. It's a dream. It's a dream to be in a building where you don't, where it's net zero in terms of several things. It's fantastic. Yes. It's fantastic. Wonderful.
That was great, Karl.
You really tripped there, Karl.
No, I think he's pretty much laid it all out, right? This is broadly what we are really talking about, right?
And I think the idea is to simplify it. I think we've all got too
absolutely. But Karl, the other thing really is, I think this is also, which is quite interesting in terms of the opportunities available. 1 second, do you want to do this kind of, let's say, later, let everyone finish their presentations and then get into conversations, or you want to do it one after the other? Just, entirely up to you guys.
I think do it now so that we can interact about with his presentation.
Yeah. So I just, I think when it actually comes to carbon negative construction, I mean, whatever we do, steel, concrete, glass, aluminum, you're not going to be able to kind of balance. It's very hard to balance it out, at least in terms of most of the studies that we've done. So generally speaking, for that kind of, let's say, carbon, neutrality, you really need to start looking at carbon negative construction. So we are currently exploring kind of CLT, cross-laminated timber, and glulam as ways to actually build and construct. At this point in time, unfortunately, India doesn't grow. We don't have sustainable forests. So kind of sustainable forestry is essentially looking at fast-growing kind of temperate species where you can harvest wood within, say, 10 years. Across Europe, North America, Japan, China, Russia, etc., over the past kind of 20 years, these or these countries have invested in large tracts of sustainable forestry. Which is why you have companies like kind of Canadian Wood, etc., trying to kind of market their wares in India. The thing that we need to understand is even if we were to import kind of timber from abroad, the cost of bringing it here is still going to be offset by the amount of carbon that you've already actually pulled out of the environment through the trees that you've used. So I think kind of carbon is kind of huge. The other is, of course, stone or whatever you kind of draw out of the ground itself. And the third, obviously, is, other kinds of, materials that you could use. And I think what's incredible about India is that we have this amazing kind of history and tradition of natural building materials. So the point, I think the trick often is that, when people ask me, about this, that and how are you going to control costs and how do you build to scale? So these are really the two challenges that we face, right? Because it's all well and good to be able to build homes in small communities. But the moment, we're talking about scale. The challenge of India is always going to be scale. So how do you begin to really scale this up, where that kind of carbon neutrality, even in terms of the material base of what you're doing, is something that we can all begin to look at. So we're really trying, we're actually pushing hard. We're talking to a few companies today to really start to look at kind of timber construction as another way to begin to offset kind of carbon.
Karl, one big thing I thought, which is a big nail on its head, and rather two big nails on its head. The first one is to go back and measure it, right? If you're not going to go back and see what you built or get data points out of it. And the second big nail on its head, like you did with your net carbon as well, that every asset has a much longer life than it takes to construct it. Sort of setting out of goals is not about what you're going to build and start operating tomorrow, but once you've started operating through the next 15 or 20 years. So I think those are two big nails on its head. Bringing trackability of what you've built and having a much larger vision for what an asset cycle is. It's not 2 years, 3 years, it's constructed.
Absolutely.
What I will talk about is something that we have done are in the process of doing. Of course, much is spoken about net zero and carbon-free buildings. But what I wanted to talk about here is a case study that we are doing and on a net zero approach more than actually a building, on how we design buildings. So of course, we all know, and much has been spoken already about the passive design for the buildings and to reduce the consumption. And that's the start point in how we orient buildings, the use of materials, and so on and so forth. But the important part today is technology, and how do we implement technology into the buildings and integrate that as systems. So we all know that we have a lot of systems that are already functioning within buildings, and they're all still currently working in silos. So a converged methodology is the best, and I will come to that going forward. The third being offsetting the energy requirements, and Karl spoke about solar energy and hydro and wind energy, of producing energy to set off the energy consumption. So coming to a case study of what we are doing currently, it's for a commercial building. Now, getting net zero building for commercial and high-rise buildings is extremely difficult. When it comes to a school and a much smaller scale, it's much simpler. We're doing a school through our other firm, EDA in Singapore, which is targeted to be a net zero building. But for much larger buildings, which are spread across 1 million square feet, which is a high-rise building, commercial building, it becomes extremely difficult. So our design target was to have 70 kilowatt per hour per square meter per year. That is what we started off with, and this is a high-rise of going 32 stories high and to about 1 million square feet, and to accommodate close to about 10,000 employees. So starting with the evolution of the form, it was a more rectangular, straighter shaped site. So the best way was and you see on the slide, the ideal orientation would be north-south, and we had that by default. We thought of 2 towers that would come up to consume the FSI and to maximize this usage of space on that building. And then we came to converging volumes, and we tried to put the buildings together. And in doing so, what we started doing is creating self-shading buildings, which were giving shade to each of these buildings, which thereby reduced the load and energy consumption onto the buildings as well. And then we added the expression to the building by adding the twist in the 3rd dimension to create an interesting form. And what you see as the next one is the form starting to get created. So we added the twist and the tilt. Now, in doing so, and as you see on the plan, we started getting extremely high quantum of shaded surfaces by virtue of one building shading the other, and with the twist and the tilt of the building, we started getting shading elements onto that. Now, to further enhance that, so here you see the angle at a 24-degree angle, the tilt within that. We then mapped all the heat gain on all the surfaces, and each and every surface was mapped to see what kind of heat gains are coming onto each of these surfaces. What we then did is broke that up and used that entire study and broke that up into shading devices. Now, we created this structure in a manner where it has the central core, and it's got an entire diagrid structure at the periphery, which held the entire structure up. So you get a column-free floor plate. But in doing so, it also gave support for the glazing system. So it didn't become a structural glazing all the way through. Each diagrid became a system on its own. And within each diagrid, depending on where it sat within the surface of the building, we had different shading devices that were created. So there were 6 different depths of the shading devices that were created. So they were like bird beaks that you see on the screen right now. And there were 6 different modules that got created and 6 different typologies of diagrids that were created. So you had a permutation of 36 different typologies within that entire surface. So the facade panels started to look like these, and they were of various depths, starting from 900 to 750 to 600 mm. So all of them were different. So you had 36 different panels like these, and this is an image of just 6 of those, and all put together, it started to look like that, and started to get the heat reduction into the building. So those are images of what the building would look like. We had connectivity onto the 2 buildings also that we created at various levels. That's a view from the bottom looking up. And in terms of the materiality as well, we said we will not use any blinds, no shades, but still have no heat coming into the building. So we had the use of smart view glass, which tinted depending on the amount of light coming on to that surface. Transparent solar cells, again, fully transparent solar concentrators, which could turn any window or sheet of glass into photovoltaic solar cells, which then thereby created energy. And as part of biophilia and wellness, from a wellness perspective, the silk leaf also was used in the glass, which actually created energy and emitted energy into the building inside. So all from a climatic response from an energy generating and from a wellness perspective, the entire facade got created. Coming to the second part, which is intelligent buildings and development essentials. So when you design smarter buildings, and much like my previous colleagues have mentioned about smarter buildings and the word, how the word has been used and used and abused, I would say. But this is more on how the system should get followed. You first need a building backbone. You need to identify use cases. That's the approach you need to take. Post that, you need vendor risk management, of course, and then the entire development process. So like I said earlier, all buildings, at least all commercial buildings and most modern commercial buildings have systems. So you have a HVAC system, you have a video surveillance system, you have air conditioning systems, you have a parking system, elevators, lighting, and advanced metering systems. But currently, they're all working independently as a system. Each one has a computer that gets connected to, and then you have some integrator that combines all of these. But the way to do it is you have and that's what we call as working in silos. What we need to do is converge all of these. And when you start converging all of these systems, you will end up with being able to do multiple or innumerable use cases that can get developed to create various user experiences and save energy tremendously. So that's a typical way of how a converged system would work. And it could also get connected to the smart community and even to public utilities, to traffic, to weather conditions, and you can have your buildings connected to at a more community level as well. Some of the smart use cases that we have figured out, I will come to some of those. And that's a building which probably you're all familiar with. It's the Hudson Yards development in New York. And I'd like to share that at DSP, we are now partnered with a company called IB, that stands for Intelligent Buildings, out of North Carolina, to provide smart building solutions and consultation services in India and Southeast Asia and EMEA as well. So there are a bunch of 46 people across in North Carolina, and we have 10 people here in our Bangalore studios, along with a CTO that we've employed to provide these services. IB has done this building for Time Warner, which is a building within a building, which has the entire systems that get connected and everything comes onto a dashboard and all use cases get met. So here's a typical use case, which could be as simple as how do you get an employee from the street to the desk faster? And we're saying it's not a parking control system, but it's 4 or 5 different systems talking to each other and creating this as a use case. So you will have, let's say you're coming in through the parking, you have the parking system that talks to the digital signage, that talks to the lighting control, right up to the elevators and getting you into the office space, right up to your desk. So it creates a different experience also for the end users. Likewise, the touchless entries, that can become another use case. So again, what you have is your parking system talks to your access control, it talks to digital signage, and then to elevators as well. Likewise, another use case could be density and social distancing within the building. So it could talk to your HVAC systems, to your lighting control, digital signage, and the access control. All of these start talking to each other, and then you can create that as another use case. Another one could then go on to as environmental monitoring. So you have the HVAC system talking to the life safety systems and the digital signage.
Tell me, those 2 buildings The commercial building which you said were in Singapore?
No, they're in Bangalore actually.
Bangalore. And how big is the site?
5 acres. The entire site for the campus is 63 acres, but this sits on 5 acres.
And
So it's a very dense. So it's a very dense part of that site. It's actually a horizontal campus, and there was only 5 acres left out of that on which we needed to consume all of that real estate, the FSI.
So how much have you built there?
Not yet built. This is still at design stage.
No, but how much is being built there on 5 acres?
On 1 million square feet. 1 million square feet.
So 2 buildings, $500,000 each.
Yeah, that's right. That's right.
And what would a building like this cost?
This would cost about 4,000, in excess about 4,000 square feet. Again, depends on what you add onto that. The technology bit adds up a little much more to that cost.
Okay. I mean, because being in Bangalore, whether they can afford it or it's for self-consumption?
Self-consumption. It's not to be leased.
Okay, because I think this kind of a building may be difficult to lease in Bangalore.
It's one of the top, one of the largest software companies. So it's affordable for self-consumption and for the ROIs that they will get.
Yeah,
also, it's more about branding as well for
No, nice, excellent, superb presentation, Yatin. Fantastic. Oh, you're back.
I'm back. Okay, I keep coming on and off. These are the privileges of the Hamptons, Vivek.
I'm sure you practiced that line because calling it the Hamptons.
Well, I just heard it yesterday from you guys.
Oh, there you go.
Just being humble.
So I'm just kind of curious here. Also here, Yatin, your entire all your partnerships with the engineering and the sustainability consultants were all local or a mix of local and international. I know you kind of mentioned this office out of North Carolina that you're working with in kind of intelligent building. So they are working with you on this project, or are you also partnering with local offices to kind of?
So it's a combination of both. Kapil. It's
right.
Local as well as international, and DSP has partnered with IB on a longer term partnership. It's not just a one-off on a particular project. We are an entity now called DSP IB to provide integrated architecture and smart building solutions as a consultation on its own. And this being one of the projects that we will do.
I see. Fantastic. No, they just make so much sense to create kind of synergies with the institutions that are already doing this and to be able to offer that as a comprehensive service.
We're actually the only company globally that has this as an offering. So I've spoken to quite a few large firms, and I'm wondering why no one's ever got around to doing that. But IB on their own, they've been at it for the last 15 years, just providing smart building solutions and consultation for that. And we've been in talks with them for the last 2 years now. So 2 years pre-pandemic, and the pandemic now is just a catalyst to encourage people to get into to use more technology for their buildings and their interiors. Make buildings more smarter.
I mean, we've got the classic Indian problem as well, yeah, with all these stars. We've been a UK JV for 15 years, but everything in India needs to be cheap. But I'm saying cheap, not necessarily cheap, but when you compare it to any international practice, you're way cheaper because probably your cost of construction is low as well. So, I mean, that's a large challenge, I think, that international practices that we've known and we ourselves have faced in terms of setting context or setting the man-hour cost to what an Indian client would pay for. It's a journey of its own. It's amazing to see.
But to expand on that, and while we say that we are cheap, it's still considered to be very expensive. And the immediate question Vivek asked was, how much does a building like that cost? Right? So that's the immediate response you get, or reaction that you get. I remember we did a building in 2000. In the year 2000, it was a cable stayed structure. So you had a central core and all the buildings were suspended on cable. Quite like our ceiling, same technology that was used. Everyone asked me, how much did it cost? I mean, like, costed $50 more per square foot. that's it, But it's about perception. So
I mean, it's about in India also. It's a great deal about volumizing these unique things, because then they become cheaper as well contextually. I mean,
absolutely.
As islands, probably on one project they become too expensive. But somewhere where Karl also was talking about that, copy it as nicely as I can say it, that we effectively copy. But that's what it is, right? What works, you sort of copy it, make it working for more numbers, and hence the end consumer is not paying as much. I mean, that's when all of us have a job, at least we do, with that.
So I was talking the other day to someone, one of our, vendor partners, and we're designing this smart partition. Okay, the partition that talks to, and they were wondering, like, will it sell? It's going to be expensive. And I said, your approach, your marketing approach has to be different. You have to tell somebody that you are now giving a partition that is free of cost. It is going to pay for itself in the next 2 or 3 years. So why would someone not buy a partition system, that is intelligent? So it's just about perception. It's how you put it, basically.
Yeah, but tell me, you were saying contactless entries. Is it by facial recognition that you walk through without having?
So it's a combination of everything, right from your parking, your access control there to facial recognition there. Even your elevators, you have voice controlled elevators, so it's absolutely touchless.
I mean, secretly smart is about that, right? Multiple technologies collaborating with each other. I mean, sort of Bluetooth tech with the ID cards is one great way of tagging people and keeping the entries invisible. But you're right, finally smart is about how 2 or 3 technologies collaborate with each other, so that you've not left any stone unturned and being conclusively saying that this is what it is in some sense.
So, and Vivek, we're not just talking about user experiences in a commercial building. Today, airports are being designed with touchless experiences all the way up to the to your exit point or your port of disembarkation. And just your baggage pickup is where you have touch and feel. Otherwise, from the time you get out of your car to get into the airport to your destination, it's a touchless experience. That's being created now. And we're seeing some of them now with the pandemic. So that's what I mean. The pandemic has been a catalyst to utilization of smarter tools now. We were riding it slowly, but now the pandemic has, kind of been a catalyst to improve all of that. Yeah.
Do they have a solution for showrooms as well?
Could be. Yeah, you could, because it's just a matter of systems that talk to each other. And you can create innumerable use cases.
Yeah,
so again from touchless systems, touchless entry to whatever. Yes, even showrooms.
I mean, to be honest, the problem of less is more is that the goals have to be set, and they just have to be a few. All concept technology can orchestrate to fulfill that goal, but the key is having only a few goals. More often than not, when you think of technology, you think ye, and then you're not getting efficiency out of any of those. The 80-20 rule, like everyone loves talking about these days. But I think we should we should sort of move to Kapil as well because we're running out of time. I'm conscious that I might get only 3 minutes to present.
Okay, I will in fact, I think, Karl and Yatin have already done such an amazing job. I'm just going to go very, very quickly to, I will just flip over to, can you see my screen?
Yeah.
So I think in terms of, everything that I think Karl and Yatin have framed in terms of net zero, I think, these are, pretty much the kind of broad-based values that going to see the architects as well. And I think, we're effectively and actively now trying to kind of promote these goals with all our clients. I mean, of course, we have various types of clients, some that need to be educated and they can begin to understand the kind of long-term benefits of these investments. There are some who are already kind of, let's say, converts. I'm talking to you all about a project that was finished by CD Architects kind of early last year. This is the new School of Design and Environment at the NUS campus in Singapore. And the dean of the school wanted to build this as a project that would become a marker, for kind of net zero energy construction in Singapore. It's not a very large project. It's about 120 square feet, and the population of students is also fairly low. But having said that, we were given a fairly tight site, as you can see on the top of this hill, and essentially kind of the broad kind of type that we were actually looking at. When we talk about type, we mean what are the kind of existing historical buildings or configurations that you see that have kind of responded to kind of the climate in a kind of interesting way. Historically, for us, would be kind of Rajasthan, the kind of natural kind of ventilation cooling systems that you see intelligently designed into these old buildings. Here it was the Malay house, which is essentially a house that's raised above the ground to allow kind of cross ventilation. So we essentially have moved away from the idea of a large box, an insulated box, as you can see in the first slide, which is crossed out. And we kind of created a organization of spaces which is stacked, these kind of large kind of platforms that are open to allow the prevailing kind of breezes to move through. Shade is king, and a large oversailing roof, which would also have the entire bank of kind of PV cells that we could have. But to begin to look at these as fundamentally kind of passive design kind of measures that would begin to inform the way that the entire school is organized. So this is here, as you can see, a kind of finished image of the project, as it just kind of pops up above this large grove of rain trees on the campus. And here we have a kind of an array of kind of photovoltaic cells on the roof of the building, which kind of generate close to around 500 megawatt hours per annum. So here, in a certain sense, again, very quickly, a typical kind of building with a business as usual kind of solution would need about almost 2,000 megawatt hours per annum. But we could fundamentally on our project only generate about 500 megawatt hours. So how do you actually bridge this gap? How do we create a 75% reduction in the energy consumption of the actual building as a whole? So one is, of course, very, very simply put, that you move away from conventional air conditioning to something which is essentially talking really more about adaptive comfort. So what we're saying is that as long as you can move the air around a person's body, even at an operative temperature of 29 degrees Celsius, you can actually create a tempered environment, which is actually very, very cool. So, here, if as you can see, is a kind of, let's say, cross section through the building, but what's interesting here is when you begin to see, how the air conditioning system has been designed to kind of fundamentally lower by almost 60% the actual demand. So there's a combination of spaces which are kind of fully air conditioned, but that's only around 17% of the building. So your kind of technology, kind of laboratories, all of the spaces that have kind of equipment which will require a much lower kind of temperature. Those have been fully cooled, but that's only 17 degrees. About 26% of the spaces like the libraries, studios, etc., are kind of a hybrid design, right? Which means through a, having HVLS fans or kind of systems which will kind of reduce the overall demand. And 46% of the school is completely is ventilated naturally. And this, in a certain sense, also begins to feed back on the kind of pedagogical model that we have, which I will describe later. So here you can actually see how from 1947, we slowly made our way back down to around 497 megawatt hours. And we eventually managed to achieve, a net zero energy kind of project. In fact, that's about a saving of approximately 180,000 Singapore dollars a year in terms of, in terms of consumption. So just kind of talking a little bit more about the kind of passive design measures. As you can see, we have these very large overhangs. The buildings are, of course, oriented east-west. But the idea of the large format kind of cross-ventilated spaces also has to do with this idea or this kind of pedagogical idea that learning no longer happens in the classroom. In fact, we're more interested in kind of loose learning spaces, which are more informal, where even circulation, kind of corridors, breakout spaces are really where you have a large amount of interaction, peer-to-peer interaction, teacher-to kind of student interaction. And it is within these informal spaces that we believe that the life of the school and the culture of the school actually begins to unfold. So what you're just kind of, let's say, looking at are a series of large kind of naturally ventilated corridors. As you can see, the amount of light that's percolating, you can see, in fact, both ends or both sides of the building, from this one photograph. And this is what we call the actual living room of the entire school, which is this large platform where people kind of actually walk up to. We also have these automatic curtains, which you can see between the columns, which can be drawn down if you have a kind of heavy downpour. But what's interesting about this image is also where you begin to see a series of these roof lines, right, at every floor that begin to project outward to create these, these kind of shaded spaces, which allows us to have a fairly large amount of glazing without any, any curtains. And where you see this slab kind of cranking down is the crit space. And this is where students make their kind of final year presentations. The entire ceiling is just open, just as a way to kind of, let's say, reduce cost. These are the large studios. So here what we have done is imagine a school of architecture where from the first year to the fifth year, all the students actually share the same space. Again, the idea that rather than kind of creating silos within the building in terms of classes, you begin to optimize the way that you even use space. A business as usual kind of model for the school was about, it needed 30% more area. We've actually reduced the amount of area through intelligent planning by working with the school in terms of devising a kind of curriculum which allowed for 5 years to actually be seated within the same space. You can see the fans running here, and that in combination with the kind of with the other radiant cooling kind of systems that we have creates actually a very comfortable environment for these students. This is just another view of a similar space. Again, we've gotten rid of, the ceiling is just essentially it's completely open with acoustic baffles and a combination of the actual lighting. You can also see the kind of devices where we have these kind of louvers to kind of, let's say, cut glare. But it's really nice because at this kind of level, all the students get this really beautiful view of, all the kind of rain trees that are there outside. So this is, again, another kind of image of, actually showing how the entire kind of, let's say, passive design of the school is expressed from the, in the architecture. These are the kind of the kind of senior studios that you have on the uppermost level, and they can walk out onto these large decks, which are just lushly landscaped. So it's a really, really nice learning environment, I think, more than anything else. It's also kind of it's kind of adaptive in a way that's also quite interesting. I'll just explain that. So here you actually see a series of kind of staircases that kind of bring you up to, what we call the living room of the school, which is kind of, let's say, visible here. And these are all the trees that existed on the site, and we've actually kept them, exactly where they are without having to kind of touch them. This is just another view of that, of the living room of the school. And this kind of rain tree had to be kind of removed, and we transplanted it back, right in such close kind of proximity to the school itself. Here you see the large columns that kind of go up to hold up, this kind of fairly light roof, this very large roof. And the east and the west, we have these perforated aluminum screens, which are very, very delicate. And these actually cut the glare, but still allow for the actual movement of breeze. But the way we've also designed them, because, these students will be kind of, let's say, dabbling in, kind of reimagining how kind of, how to design kind of performative facades. You also have components of the building that can be moved out, allow students the actual flexibility to actually test in real time, how the kind of efficacy of the designs that they are kind of coming up with. So yes, this was a kind of project that was actually finished a kind of year and a half back. So I'm going to actually stop here, because I think it's going to be a lot more interesting for us to kind of maybe get into a kind of question and answer with you guys. So this just kind of very quickly kind of shows one of our recent kind of net zero energy projects. Currently, we're doing a large township, about 700 flats, in Maharashtra, for a local company, which will be a net zero energy residential campus. We're actually doing, it's for staff housing, but, we've convinced the client to invest in district cooling, because by using, let's say, district cooling in a kind of residential campus, rather than having 1,200 individual kind of package units kind of belting out heat and, the inefficiencies associated thereabouts, we're kind of bringing the air conditioning costs down through district cooling by almost 50%, around 48%, which will kind of reduce with inefficiencies to maybe 40% over 10 years. So the fact remains that, given the kind of the kind of tropical, subtropical environment that we have, these are not unique strategies. It's just simply a function of the kind of consciousness of society as a large, where we need to push people to begin to say that, hey, we have to do this. It is almost now a ethical issue. It's no longer a design advantage. It's about ethics, given the times that we live in terms of climate change, the ravages of drought and the cycles of drought and flooding and everything that we're actually seeing. I think this really, is not just a new paradigm. I think it's the only paradigm for the future.
Kapil, I had a question.
Yeah.
Did it help that your site was in Singapore on the equator?
Okay, so my solar panels were largely flat. They weren't sticking out.
The reason
so that,
is because we had...
of course. Yes. There are certain advantages of being, almost close to these, that close to the equator, as opposed to, but even India, I'm just saying our expanse, you build, the further south you go, in a certain sense, the entire modulation of the volumes begin to change, obviously, so yeah, we're, we can't hear you, Akhil.
Happy to have the equator. That's the bottom line. But I've seen this project a couple of times, so I think I've asked you many questions already. Sort of massaged all answers that are there.
Yeah, I think
large as well.
Yes, I'm just saying it's fantastic to have seen projects from Yatin and Karl. I haven't seen these projects before, and it's a real eye opener to me, and I'm so glad. I just think that we really need more conversations around this, and we need to be sharing data, sharing information, because this has to be open source. You really have to allow architects very quickly to understand how you can actually do this. I don't think it's about proprietary data in that sense anymore, and I was, I'm going to be giving you a call, Karl, on Monday, Tuesday, because I'm really interested in, some of the larger strategies that you've been looking at in terms of even, let's say, land management. In fact, a project that me and Akhil are now talking about is kind of very similar. This idea that, one is where we have us, this kind of intensification of resources and technologies within the city, right? The city is the pride of kind of civilization, but COVID, global warming is in a sense forcing us to even rethink the idea of the city, right? I mean, is it finally where we will have no choice but to begin to look at other kind of formats of organizing or self-organizing as we see communities, which will be even less resource resource intensive, right? I mean, all this technology, all this wiring, all this cabling, all of what we end up, inputting, putting in is still a massive amount of basically matter, right? We have to live lighter on this planet, how do you then, maybe that's another equation with kind of technology in a certain sense, right? To me, it's this kind of imagination of the hut, but which is, basically high-speed Wi-Fi connection. It could be anywhere, right? So, this whole aspect of a whole new paradigm of working and living is what really excites us now.
I mean, one sort of big nail in the head, Kapil, with regards to generally when people talk about sustainability is airflow. Airflow has a great perception of comfort. Your temperatures don't have to be as low enough if you can.
Exactly.
And one of my professors who unfortunately passed away not very long time ago, but he taught me that, blow it there. Do you feel cool?
Hey.
So it's like, so how can you make the perception of comfort at higher temperatures better using airflow? I think that's a great nuance to it in some sense.
Absolutely.
We've also learned that,
and it's immediate. It's immediate. Yeah. The experience is immediate.
This is why they say wind chill.
That's right.
Wind chill is not actually that comfortable.
No, I mean, if it's 10 degrees, but they say the wind chill could be 5 degrees. The actual temperature is 10, but the breeze is freezing the life out of the person.
Yeah, that's right.
The other passive strategy that we've picked up along the way is that it's not just about the perception, but also if you move from 40 degrees into a semi-shaded space of 33, and then you move into a space of 27, suddenly 27 is okay.
Yeah, that's right.
Absolutely.
So it's about how you sort of make the movement of the building as well.
Play with people's minds, yeah. Very good.
Akhil, you'll go now?
Yeah, I'll go now. I've effectively compiled it as flashcards, to be honest, and not sort of representing a project, because somewhere I think finding the nodes, or the simplicity of finding the nodes of what is smart is what sort of it is on. Won't spend too much time on each slide. Literally, like I said, it's compiled as a flashcard. But the bottom line, before I start and after I finish, is how can designers stay engaged with an asset even after it's completed? I think that's when the real key is, because everything can be installed, but if it is not tracked, then that installation just becomes something which is a fancy thing that we can talk about in some sense. So, anyone who's from the client side probably listening to this as well, that, don't kick us out once the building is put up, let us stay with it so that we can make it more efficient and productive for you all in that sense. So I'll quickly go on to the slides that I have. So it's, like I said, flashcards. So I'll quickly go through the pages. First, I want to set the context of what is a macro framework or the feeling that we need to evoke with smart infrastructure. So first is, it's not all about Internet of Things. It's about movement of people, energy, goods, ideas, and how, when and what data is communicated. Because a lot of data is wasteful unless it's giving you an actionable or communicative intelligence. So it's not all about wiring things up. So it's IoT, physical and communicative. And when we are talking about net zero sustainability, we are talking about objective things. But when you talk about smart, a lot of subjectivity also starts coming in terms of what's the culture of the space that's going to breed, where is the flexibility, public art, and you can see a few others on the flashcard right now. But it's more than just, sort of the physicality of the building in some sense. It's also how the people feel within the building. So basic rules of engagement, make customer or occupant related experience enjoyable, education and profitable. One of the key things is that how can you keep life in the foreground and commerce in the background? And finally, how do you generate feedback loops if you're not listening back to what you've created, and if the people or the occupants are not telling you of how they feel, if there's no feedback loop, even at a sample data level, you're almost not going to make the asset more efficient or productive. So what are the primary goals of smart infrastructure? Improved quality of life, which includes the experience of the people, the convenience, the efficiency with which they're working, and the community development. And of course, increased life cycle performance is the next big piece. So how does the asset yield go up? How does sustainability quotient go up? How do you operate the asset more efficiently, and adaptability of the asset? From context to use dynamics, sort of being responsive to the changing canvas. There is no steady state when you're designing an asset, and all the more there is no steady state once the asset moves into operation. So how can we be responsive to the use dynamics? So the first thing is the levels of activation. Okay, so the simplest, again, when we say with dashboarding, we make things very complicated, but what is the use intelligence? We've got 6 typologies or levels of activations. One is what the space is defined for. Second is circulation spaces, places where people can congregate, events, neighborhood, and remote and digital. So the key is to find out that as a design function, what do you expect the density of people to be there? What is the flow of people? And without face recognition, even get an happiness quotient of how the people are feeling within these spaces. So one thing with technology about encroaching on privacy needs to start phasing out to say that I don't need to physically know what the name or what your face is. I just need to know some empirical data of how you're feeling or how you're behaving in some sense, and that can improve asset efficiency. Multi-use of assets. I mean, we will need to, and like Kapil showed as well, that how you can reduce the amount of space required, because through the fabric of time within a day, you could use the same physical space for multiple things. I mean, of course, foldability, plug and play, satellite functions, these are some things that you can sort of key out in. And this is an example, right? So, sort of when you're looking at a canvas of a space, especially like what Karl showed, which was a larger floor plate, and you had, sort of people engaging through spaces, the same spaces can be configured into smaller and larger parcels from time to time to activate intimate experiences, family and friend experiences, neighborhood experiences, promotions and events. We don't need to have dedicated spaces for each one of these. We just need to reconfigure the spaces that are already there for only when this use is happening in that sense. So that's what brings dynamism and use. We can talk about satellite functions and mapping those satellite functions, because then you'll know that what's happening at them. So where you put art installations, are people actually waiting there? How much time are they waiting there for? Pop-up spaces, whether it's performance zones, F&B, network screens, how do you bring focal points into attention? And how do you have a plug and play system? And like when you go into an Amsterdam or a Germany or somewhere, the same space has additional toilets, drinking water points, stage performance points, without seeing any wires and cables lying on the surface. Everything is pre-planned so that subconsciously the space can change into what it needs to. Then it comes to monitoring. So we went from sort of, context to use dynamism to how do you monitor it, because a consistency in monitoring will help us adapt and be responsive on ground. Health is wealth is becoming a huge topic now, especially with COVID. You're talking about what is the hygiene of the people coming in. But if you track back healthcare, they've said that preventive care is where the cost is the lowest and has the maximum impact, reducing load on the primary and secondary care. So currently we are looking at health and hygiene by force, by COVID coming in. But there is a lot of health and hygiene that we can look at by which we can increase the fitness or the health portion of the occupants by giving them information, by rigging up spaces where there are gyms and pools so they know how they're performing, health kiosks of sort. So sort of moving away from a matter of life and death to actually accentuating the fitness and health of people that are occupying these buildings. Parcel intelligence, I think Yatin has already spoken a great deal about, and it's about creating those use cases. Sort of anything can happen, but it's not about anything. It's about those 4 or 5 use cases that you want to achieve in some sense. And then technology can be orchestrated in today's world very easily for meeting those functions in that sense. Tracking of people, workflows of how they're going to move from one place to the other, movable assets. These are things that can be easily plugged in. So monitoring can be accentuated to the extent of what are the anomalies you're tracking, because you don't want to be looking at data every day. You're saying that after I've looked at it sufficient number of times, I know these are the anomalies I want to track and these are the trends I want to track. So things from workflows, operation, occupant-centric data, and this is a slide I've picked out from what we're doing for a mother and child hospital. So it sort of is more hospital oriented, but finally it's about the anomalies and trends, not literally about every data that you can capture within an asset. This is the end of the presentation or the flashcards in some sense. I finally want to talk about sustainability, which all of you all have covered sufficiently, that it's the default setting. Sustainability is no more a design edge. It's about by default when we do buildings, we'll have to do this. One thing that we feel is very, very important, and if you look at smart infrastructure data, you will see that 60% energy reduction can be achieved by only making the occupants conscious of their use. If they know how much their air conditioning is using, plug points is using, lighting is using, fridge is using, kitchen is using, etc. Just the self-consciousness brings a reduction in power consumption. So the primary goal of sustainability should be that everyone should have a tool to track their own carbon footprint, because reducing carbon footprint doesn't need a cost. It needs care first, process second, and then it needs a cost. So like, all of us have been talking about energy and transportation contribute to 70%, if not 65% of the greenhouse gases. So you all have already shown tools to focus on energy. Similarly, sort of Karl said that how just taking one flight could sort of incur so much carbon dioxide. So a carbon footprint tracker becomes very important. We've spoken about this. I don't want to say much about it. It's passive engineering. How do you put the building in the context of the nature it's going to be in and find ways of reducing consumption? Smart electrical grids of how do you make an asset, every asset can be net zero. Not today, and again like Karl showed, it's about the journey. But at the beginning of the asset, if you've made provisions for it to be net zero in 10 years, you'll be able to make it happen in that sense. Hygiene considerations, when we talk about sustainability, is your standard lead or griha headers in some sense, but this is more like a checklist approach, and so some things that don't take too much effort to do any which ways. This is what I want to end with. I mean, I'm not going through the other flashes that I've got, but a great part of smart is how do we integrate with the neighborhood, which means how can we maximize the use of asset by cross-using things from each other and making the neighborhood more efficient at large. And it's easier to make a neighborhood more efficient versus just a single asset because you've got access to it. So I'll just leave everyone with this question. Can we go beyond our boundary walls? Sort of, will we let people from other assets or neighborhood assets enter our asset for some things and we entering their assets for some other things. So, I mean, that's it from my end. Like I say, it's more flashcards and, sort of the simplicity of what we need to achieve. How to achieve it is something that I think all of us are supremely capable of, connecting those wires in some sense.
Akhil, can you also call in the girl behind the man?
Fanny is in another room, but I'll call her. She'll come in 30 seconds.
Call her because we like to say hi to her.
Yeah, for sure. I think she's hearing it, so maybe she's already on her way here.
Yeah, wonderful. But I found this entire panel session really educative, really educative, and this is the way to go. I hope clients are listening to you guys. Yeah, I hope clients are listening to you guys. Hi, Fanny.
Hi, Fanny.
Hi, Anikaa. Hello, Yatin. Hi, Karl. Hi, Kapil.
Hi.
I guess you guys are having a great session. I've been hearing you guys outside.
Wonderful.
But I think that was good, Akhil, and you rightly said that we need to go back to our clients as well. The clients need to realize that whatever we are installing as technologies and things like that, that we need to go back with analytics to tell them how. So a small example of space utilization tools. You track it all. You track how the spaces are utilized. In an office building, workstations are used, meeting rooms are used differently from what they were planned. And you can go back to them and say, just by sitting on data, you're not achieving really anything. You've installed technology, you've got the data, you do the analytics and go back and tell them that, you can use your space much more efficiently. And it all pays off every day. So clients need to realize that architects need to come on to a SaaS model as well, and it's no longer the one-off. It's no longer the one-off fee. When a client engages us, we are married to them for life. Quite like how we have our software licenses, Karl and Kapil. Every year we pay a license fee.
We have to.
So all our customers need to start paying us license fees. So let's look at the word like that now. It's not AMC. It's not AMC, Vivek. It's a SaaS model. We do work for them. It's not just come there.
And we'll consistently analyze data for them. From one office to the other. If one place is getting efficiency, we'll show how efficiency can come to another place. I mean, this thought needs to be cartelized, and you guys are like.
No, but clients will realize the value. Clients will ultimately realize the value that we will bring to the table by giving them these services from time to time. So I think we all need to switch to that model, because anyway we are being paid pittance, so we might as well take our fees in installments over time.
We take pittance every month for 10 years is okay.
But they're already paying us, just the advance amount, so to speak. We still haven't got on to getting our actual payments, right, Karl?
I think it's time for lunch. And for your Alibag afternoon snooze.
No snooze. No snooze. I wouldn't want to waste the time on snoozing. I breathe in the fresh air.
Okay, guys, thank you so much.
Thank you.
It was a really good session. Really good session. One better than the other, and it was delightful having all of you on. Thank you so much for coming on, and we hope to stay in touch. And there's an invite for all of us to get together at my house when all this is over.
For sure.
Great, thanks. Thanks, everyone.
Okay, guys. Thanks.
Bye.
For great meeting you all. Great seeing you all. Great session. All the best. Bye.
Bye. Take care.